Okay, guys, so we're going to do some word problems. We're going to be using rectangle formulas and right triangle formulas, and we're not going to use all of them, but here's just something to reference. Perimeter area of a rectangle, Pythagorean theorem, area, and trigonometry. We're actually not going to use any of these for a little bit, but okay. So, guys, every time we do a problem, I'm going to do 3, and I just wrote these down to make things faster. We're going to have a picture. Okay, so this is going to be our changing picture, our momentary picture, and then we're always going to want to ask ourselves, what do we know, what do we want, and when? Because in calculus, when you're doing word problems in calculus, uh, sometimes there are things that are constant, but there's other things that are changing. And there's changing at different rates. And because we're looking for, because we're dealing with certain rates of change, we're going to have to use derivatives and, things like that. Okay, so here we go. So a right triangle has side lengths that are changing. One leg is increasing at a constant rate of 7 inches per second. Okay, so we got one leg is increasing at a constant rate of 7 inches per second, while the other leg is increasing. The other leg is increasing at a constant rate of 9 inches per second. What is the rate of change of the hypotenuse of the triangle? So we want the rate of change of the hypotenuse of the triangle at the moment the above mentioned legs are 12 and 16 inches respectively. Okay. So at the moment, all right. So our changing picture, we are going to be labeling with only variables. Okay, so I'll let that be A, B, and C. So the changing picture, you never label any numbers on the changing picture unless it is a number that is always the same. But then on the momentary picture, this is where we could put in a couple things. So one leg is increasing at constant rate, or you don't put rates on a picture. Well, the leg is increasing. Okay. At the moment, or actually, let's fill this in. Let's fill in no, want, when. All right, so what do we know? We know we've got a leg that is increasing at a constant rate of 7 inches per second. So we could just label one of these. So let's say that it's the A. Let's say that leg A. So dA dt. In these word problems, everything is changing as a function of time. Okay, so time is always the input variable. So dA dt. So everything's going to be something over dt. Because this side A changes as time changes. So time is the input variable. A depends on time. So dA dt equals 7, positive 7 because increasing. While the other leg is increasing at a constant rate of 9 inches per second. So that would be dB dt equals 9. What is the rate of change of the hypotenuse? So we want dC dt of the triangle at the moment the above mentioned legs are 12 and 16 inches respectively. So when A is 12 inches and B is 16 inches. And I can go over here and I can label those on my momentary picture in case I need them to find something else at that moment. Okay, so after you fill in the changing picture, the momentary picture, and then no, want, when, and as we do more of these, guys, you'll have your own sort of process. So you might not write everything I do, but please do for as we're learning it to begin with. Now, what you do next is you look at the changing picture and you ask yourself, you look at the changing picture, you look at the variables that are involved, A, B, C, and you think of formulas, a formula that would involve the variables on your picture. That would be Pythagorean theorem. And then you write that down. You go a squared plus b squared equals c squared. Now, guys, somehow we need to involve our derivatives. So you would take the derivative of this. And we've done this before. And guys, everything gets a prime after it because it is t that is the bottom. So remember, like before when we were learning implicit differentiation, if we saw something like this, we would say a prime after a. If we saw something like this, we'd say b prime after b, c prime after c. So everything gets a prime after its derivative. So normal derivative 2a gets a prime after it. Normal derivative 2b, b prime. Normal derivative is 2c, but then you get a c prime. Then you look at what you want. We want c prime. So I'm going to leave a placeholder for everything except c prime. I need to plug a number in for all of those things, and then I'll be able to solve for c prime. Okay, well, what can go in for a? At this moment, a is 12. At the moment we care about. How about a prime? That's dA dt, so 7. And for b, at the moment we care about, it's 16. And for b prime, that's dB dt, that's 9. Now in for c, this is why it's important to label the momentary picture. Because at this moment, when A is 12 and B is 16, they're not always that, but at this moment they are, we could use Pythagorean theorem to find what C is at this moment. Okay, so we can go 12 squared plus 16 squared is C squared. So you end up with C squared equals 400. C is 20. I'm pretty sure I already did it. I'm just trying to save us some time, guys. I think I already did it. Yes, it's 20. So 20 goes in there. All right, so you're going to get 40C prime equals 456. So C prime equals 11.4. And you need units. This is a rate of change. So it's going to be something per something. This is inches per second. Okay. Now, guys, we do have two more. Okay, so there's one. Problem number 2. We're going to have rectangles. And when you're doing your problems in class, I'll only give you 3. You're going to have a changing picture. You're going to have a momentary picture. And then you want to think about what do you know, what do you want, and at what moment. Because these things are changing, so it needs to be at a certain moment in time. So you've got a rectangle. It has side lengths that are changing at constant rates. The length is decreasing at a rate of 7. So the length is decreasing at a rate of 7 inches per second. The width is decreasing at 9 inches per second. At what rate is the perimeter changing? At what rate is the perimeter changing when the length and width of the rectangle are 11 and 8 inches respectively? Okay, so for our changing picture, length, width. Let's do know what when. We know dl dt, and if any of this needs to be clear to you guys, if this is not clear, pause and think about it. Okay, so dl dt equals -7 because it's decreasing. The length is decreasing, so that would be a negative derivative. Okay, oh, excuse me, the width, dw dt is also decreasing at 9 inches per second, so -9. At what rate is the perimeter changing? So we want dp dt when the length and width of the rectangle are 11 and 8 inches respectively. So when L is 11, width is 8. So 11 and 8. Okay, then you look at this know, want, when situation. What variables do you see? well, we've got time, but everything is a function of time. But other than time, t, we've got L, W, and P, perimeter. So guys, you're going to want the perimeter formula. So the perimeter formula for a rectangle is P equals 2L plus 2W, right? Because you're just adding up all the sides. L times 2, W times 2, okay. And then you take the derivative of everything, and everything gets a prime after it. So the derivative of P is 1, but then you need a P prime. Derivative of 2L is 2L prime. Derivative of 2W is 2W prime. We want P prime, so I'm going to put a placeholder for everything else. What goes in for L prime? -7. What goes in for W prime? -9. So we didn't even need this, guys. It actually turns out that P prime does not depend on the momentary side lengths. Okay, it only depends on the rates of change of the sides. Yeah, so what we end up with here is -14 minus 18, -32 inches per second, right? I think. Yes. Inches per second. What were my first one? That was my first one. Yeah. Alrighty, one more. Okay. Another rectangle. So a rectangle has side lengths. So changing picture, momentary picture, no want when. A rectangle has side lengths that are changing at constant rates. The length is increasing at a constant rate of 6 feet per minute. At the moment when the length is 9 feet and the width is 10 feet, the area of the rectangle is growing at 33 square feet per inch per minute. Okay. What is the rate at which the width of the rectangle is changing? And then, is the width increasing or decreasing? Explain. Okay, so the changing picture, length, width. What do we know? The length is increasing at a constant rate of 6 feet per minute. So dl dt increasing, so +6. What do we want? What is the rate at which the width of the rectangle is changing? So we want dw dt. Now when is kind of complicated here. There's like a lot of things going on. At the moment when the length is not always 9. So when the length is 9, the width is 10. So when the length is 9 and the width is 10, the area of the rectangle is growing. So they're sort of implying here that the rate of change of the area is not like, that's not like a constant rate of change. So I'm going to put it in the when column. You could put it in the no column, but we'll get the same answer. So this is a rate of change of the area. So it's not the area, it's the rate of change of the area, and it's growing, so it's positive. All right, so that's how I'm going to set this up. The momentary picture, 9 and 10, right? Just in case we need them to find something else. Now, I need a formula that relates the variables. I've got A, I've got L, I've got W, so I need the area of a rectangle. Now I need to take the derivative of this. So the derivative of A is 1, but I need a prime after everything. This requires the product rule. L prime W plus L W prime. I want W prime. So I'm going to put a placeholder for everything except W prime. A prime, at this moment, it's 33. L prime is 6. It's always 6 because they said it was a constant rate of change. W at this moment is 10. L at this moment is 9. 33 equals 60 plus 9 W prime. W prime equals, let me just save us some time, or actually I'll say, all right, 9W prime is negative 27. So W prime is negative 3 feet per minute. All right, now that was part of it. Now they are asking, is this width increasing or decreasing? At this moment, I should have said. And then explain. Guys, the width is decreasing because, guys, think to yourself, when are we able to say that things are increasing or decreasing? Susan's table, when the derivative is positive or negative. In this case, we know the width is decreasing because W prime is less than 0. Guys, we're doing it. We're doing word problems. Now, in the future, like on the AP test, I've seen like multiple choice. Well, they'll be explicit, like a rectangle, a triangle, this or that. But usually on the free response, it's like there's a larger context wherein you can use a rectangle or you can use a right triangle to model the situation. Okay, so we're going to work up to that. Alrighty, I'll talk to you later.